Hi, welcome back to my statistics class. So today we're going to talk about confidence interval for proportion. So in this section, we will look at what a sample proportion p hat tells about the true population proportion. And we won't be able to know anything for sure, but we can find a range of value that are reasonable for our population value. Okay, so let's do some review. Remember what is standard error? So standard error is an estimate of the standard deviation of sampling distribution of the proportion with the p-hat. It's used when we don't know the value of p and are not able to determine the true standard deviation. So remember that sampling distribution of a proportion is an estimate. We would not be able to know the true population proportion. So standard deviation is to help us to determine how far off, how various of the estimate. Okay, so basically it's the standard deviation of the proportion. So remember this one. And I want you to distinguish the difference between the sample distribution, sigma x bar, which is equals to the standard deviation divided by the sample size, square root of the sample size. Okay, so in here, let's do some little review. So I know that we always confuse about that. This is what? Sample proportion, p hat, and then x bar is the sample mean. Okay, so what will be the average of the sample proportion? We use the notation of mu of p hat, which is equals to the mean, the population mean. And for the sigma, which is our standard error, is equals to the success rate times the failure rate divided by sample size and take square root of all of them. Whereas sample mean is x bar. Okay, so the mean of the sample mean, the average of the sample mean, we use the mu x bar, which is also equal to sample mean, but the standard deviation, we use sigma x bar, which is equals to the population standard deviation divided by square root of n. Okay, so now take a look. A survey of 2,500 HR professionals showed that 1,200 used social networking sites to research job applicants. State the sample proportion and calculate the standard error for this sample proportion. So first of all, we need to find the standard proportion, the sample proportion. So what would be the sample proportion? So let's say how many people are using that networking? We totally have 1,200 people who use the social networking to search job applicants out of 2,500, right? So that would be the proportion. That's how many people among the surveyed been using the social networking site, which is 0.48. Then we know that our n equals to what? The sample size. We totally surveyed 2,500 HR professionals. Okay, the first step is we always need to check the central limit theorem. Central limit theorem. 1, independence, right? We always assume that it's independent because each HR, they're not going to affect the other HR's results. And then this is a randomization experience. Third, we need to check the success and failure rate, which is n times p equals to what? 2500 times 0.48. Oh, I don't know why there's no a, which is greater than or equals to 10. It passed the success rate, the success condition. Now we still need to check the failure condition, which is 2500 times, since the success rate is 0.48, so the failure should be 1 minus 0.48, which is also greater than 10. So that means it also passed the success failure condition. Okay, so now we need to calculate the standard error. Basically, it's the standard deviation of the proportion p hat, which is pq over n. So this is equals to 0.48 times 0.52 over n 2500. So use the Google calculator, you will get 0.00999, which is approximately 0.01, which is approximately 1%. Okay, so draw how the sample distribution model for the proportion. So remember, this sampling distribution proportion is going to follow normal distribution. So we have p hat follow the normal distribution with the mean. The mean is going to be the same as proportion, which is 0.48, and standard deviation of 0.001. So when we draw it, we will have the center is 0.48, and then one standard deviation would be you add 0.01, which is 0.49, as two standard deviation would be 0.50, three standard deviation would be 0.51, and then subtract one standard deviation, we have 0.47, and then 0.46, and then 0.45. Follow the normal distribution, and we know that within the one standard deviation, this is what? 68% of the area by the imperial rule. And then within here would be what? 95% of the total area. And within three standard deviation, we have 99.8% of the area. Okay, so based on 68, 95, 99.7, oh my god, I remember the wrong number. This is 99.7 by the imperial rule. Okay. So what do you expect 95% of sampling distribution to p hat to fall? Well, we know that 19A is within one standard deviation, and 95% would be what? Two standard deviation, and the 99.7 would have three standard deviation. So we will expect it we're expecting 95% of our sampling distribution p hat to fall within two standard error. In this case, it's called standard error. We don't call it standard distribution anymore, standard deviation anymore. But what is that? Let's take a look. When is two standard error, which is 0.46 to 0.50, right? But that's approximately. If you want to be more accurate, we need to use a GeoGebra to find out what will be the actual 95%. So now let's take a look. We have the mu of 0.48 with the standard deviation of 0.001. So that would be our normal distribution graph. And then we want x to be between certain value, so that it's going to fall within 95%. Okay, so now here you can change to 95%. So what are we going to do? Well, so we're going to use the symmetric of the normal distribution. So think about it. This is a normal distribution, right? And we know that normal distribution is symmetric. If we want the middle part to be 95%, oh, let me erase this. So we want the middle part to be 95%, right? So that means the two tails is going to be how many percentage? So the total area should be 100%. So you subtract 95%, that means these two parts has to be the sum of these two parts. The left part A and the right part B should equal to 5%. Since they're symmetric, so they should be equal. So that means this should be 2.5% and part A should also be 2.5%. So now we're trying to find the cutoff value, right? So now take a look. That means if we can find this part or this part, oops, sorry, the 2.5%, whenever x greater than that, then we will find the cutoff value. We do the same thing for the left part and the right part. So now let's take a look at GeoGebra and see how we're going to do that. So let's say, hey, when x greater than certain value, so that we got 2.5% of the area. So we will find the upper bound of the cutoff value would be 0.49996. Okay, so let me write this down. So the cutoff value to the left is 0.49996. And then let's take a look at the other side. So now we're trying to find the left side, the cutoff value, which is we're trying to find also the 2.5%, which is the cutoff value would be what? 0.4604. So here our cutoff value would be 0.4604. So that means instead of writing, this is approximate, right? Within two standard deviation. So to be more accurate, the confidence interval should be 0.4604 to 0.4996, which when you approximate it, you will get 0.46 and 0.50. Okay, so how do you understand what is confidence interval? You can think about that as when you try to catch a fish in a lake. If, let me use this one. Okay, let's say our p hat, which is a sample and distribution proportion, is the fish that we're trying to catch. If you just use a single line trying to catch the fish, you throw in a line and hopefully, hey, the fish will get on the hook and you will get the fish. Do you think it's that hard? It's harder, right? So the best way to catch a fish is what? You try to use a net, a fish net. So think about there's a fish net, maybe this size. So that gives you better chance to catch the fish rather than just use a single hook. So this fish net, we call it confidence interval. But the bigger fish net that we use, the better chance that we will catch the fish. So that means when the upper bound and lower bound is bigger, the range is bigger. That means the percentage to catching the fish is going to increase. That's how you're understanding the confidence interval. Now let's do a couple more exercises to understand what is confidence interval. So in here, between what two proportion do we capture exactly 95% of the value? Write the interval that represent the proportion. So I showed you the example earlier. So in a normal distribution, it's not like this one, right? A bell-shaped curve. Not just a bell-shaped curve, it's a symmetric bell-shaped curve. So we want to catch exactly 95% of the value. Remember, it's not to the left, or the left 95% or the right 95%. We want to catch the middle one because our goal is to catch the fish, which the fish is in the middle, called p hat. So in order to do that, we need to create a fish net, which is 95% of chance that we're going to catch that fish. So how do we do that? So because it's symmetric, that means we just need to measure the two tail. It's going to make up 2.5% of the value. Then we can find the cutoff value, right? This is the lower bound. And this one is our upper bound. Okay, so how do we do it? So let's assume that this is a standardized normal distribution. So what is a standardized normal distribution? So that means the center is going to be 0. A standardized normal distribution is called Z. We did that in the earlier classes with the mean of 0, which means the center is 0, and then with a standard deviation of 1. So let's see how far off to catch 95% of the value. So now let's take a look at GeoGebra. Let's let this become a standardized normal distribution. Okay, so this is standardized. Again, in order to catch 95% of the value, we want to find out, hey, what's the 2.5% of the value on the left and another 2.5 value of the right. So let's find the left one first. So we want it to be 2.5%. 2.5%, which is 0.025. So the cutoff value is what? Let's round up to 2 decimal places. So it's going to be negative 1.96, right? So we know that if for a standardized normal distribution, the cutoff value here would be negative 1.96. So because this is symmetric, so this is going to be a positive 1.96. If you're not sure about that, let's just use, because this is 0. This is really important because our center is 0. So that means the left part is going to equal to the right part because it's symmetric. But if you're not sure about that, we should do it again from GeoGebra. So let's find out the left tail of 2.5%. Where's the cutoff value? So look, we round up to 2 places of decimal. So we end up with a positive 1.96. So that means if we want a 95% of the value of a standardized normal distribution, we want it to be above or below the mean 1.96 standard deviation. Okay, so now let's get back to our earlier question. So in the earlier question, that we don't have the standard mean of p hat, right? Earlier, we have our proportion equals to what? Our proportion is equals to 0.48. So now let's find out its upper bound. Its upper bound should equals to the center plus 1.96 of the standard deviation, which in our case should be 0.001. So use a Google calculator. You will get, hey, this is equals to 0.4496. And now also we need to find the lower bound. The lower bound should be the standard mean, which is 0.048, subtract 1.96 times its standard deviation, which is 0.001. So use a Google calculator, you will find out that, hey, this is equals to 0.4604. So that means if we just by calculate it, not using Geogebra, we will find out that, hey, the lower bound is 14604, and then the upper bound would be what? 0.14496, which is exactly the same that when we're trying to find it on Geogebra. So that means for confidence interval, we can find it by calculation. So here is some property. The confidence interval for proportion. So we need to use a sample proportion, which is our p hat, plus or minus the z-score. The z-score, we need to find it later. And then times the standard average. This is the part is standard average or standard deviation of proportion, sigma p hat. Okay, z, this part is z-score. I'll teach you how to find it later. So this creates an interval possible value for the true value of the proportion. Remember, this basically is trying to create a fish net and tells you that, hey, how many percentage with this fish hat, I'm sorry, not fish hat, with this fish net, how many percentage that you're going to catch the fish with this fish hat. So by the previous, we know that, hey, if we want to catch the fish, we want to have 95% of chance to catch the fish, which is our p hat. We want the z-score equals to positive and negative 1.96. Okay, so this is called the critical z-score, is denoted z star and determined by the confidence interval. And then also z times square root of the standard average, which is the critical z-score times the standard average, also called the margins of error. Okay, this is just turns. Don't worry about that. I'll give you in the test or in our homework, it's open note. So you can use the formulas. You just need to know how to use it. I'll give you more examples later.